Hi, in this video I'll help you get to know your car a little better. At the end of this video I've put together a straightforward infographic that summarizes all the key points. Like, subscribe and comment below. It really helps.
All right, listen up. If your dashboard is lit up like a Christmas tree with a whole storm of engine codes and your mechanic is just scratching their head, this is probably the most important thing you're going to hear all day. We're about to break down a very specific and catastrophic engine failure that gets misdiagnosed all the time, and it costs people a fortune. And look, this isn't just some guess. The pattern is now crystal clear. If you're seeing codes for your throttle position sensor, your fuel rail pressure, fuel temperature, and a bunch of injector failures, all at the same time, you don't have a bunch of different problems. No, you've got one single, devastating root cause. So how can we be so sure? Well, it all boils down to what I call the smoking gun diagnosis. The secret is in understanding how two fault codes for the exact same sensor that seem to totally contradict each other actually point to one very specific failure inside your engine's computer. Now this right here, this is the combination that cracks the whole case. You're probably seeing a P0220, right? That's just a general fault, kind of vague. But the real clue, the smoking gun, is this P0223. And that's not general at all. It's a very specific high-input fault. Getting both of these together, that, my friends, is everything. Okay, so what in the world does high input even mean? Well, think about it like this. All your engine sensors, they're designed to run on a super precise 5-volt signal from the main computer. A P0223 code means the sensor's screaming that it's seeing voltage higher than that 5-volt limit. And here's the kicker. That should be physically impossible. A sensor can't just invent voltage out of thin air. It's a huge red flag that the power source is the real problem. And that points us to one and only one conclusion. The internal 5-volt regulator inside your powertrain control module, the PCM, the brain of your engine, has failed. It's toast. Now, this can happen for a lot of reasons. Years of getting hot and cold, just old age, or maybe a past voltage spike finally took its toll. Whatever the cause, it's given up the ghost, and now it's blasting this insane, unregulated high voltage all through your system. So let's talk about the damage, because this one little failure creates this devastating cascade effect. The best way to picture it, imagine a massive power surge hitting your house. It doesn't just take out the TV, right? Nope, it zaps through the wires and fries every single thing that's plugged in. Your fridge, your computer, everything. That is exactly what's happening inside your engine right now. So here's the play-by-play. First, the regulator in the PCM just lets go. Instead of a nice, clean 5 volts, it's pumping out 6, 8, heck, maybe even 12 volts. Second, that surge of electricity hits all the sensors on that circuit. Your throttle sensor, your fuel pressure sensor, poof, they're instantly fried. That's where that storm of codes comes from. And finally, that same voltage surge attacks the injector driver circuits right inside the PCM itself, killing them and shutting down whole banks of cylinders. Okay, I know what you're thinking. This sounds absolutely terrible, but how can I be 100% sure before I tell my mechanic to do something this expensive? Well, I've got good news. There is a single, dead simple test that will give you 100% confirmation. It takes 5 minutes, and it leaves zero room for doubt. All right, pay close attention here. Step 1, and this is absolutely critical. You have to disconnect all of the affected 5-volt sensors. This stops any more damage from happening and lets us isolate the circuit we need to test. Okay? Then, you just turn the key to the on position, don't start the engine, and grab a multimeter. You're going to test the 5-volt reference wire at any of the plugs you just disconnected. Now, if everything is okay, your meter should show a nice, steady 5 volts. You might see 5.1, but it's going to be right there in that ballpark. That's a healthy system. But if you see anything over, say, 5.2 volts, and especially if you're seeing something crazy like 6, 8, 10, 12 volts, game over. That's it. That is 100% confirmation the PCM has failed internally. I'm telling you, there is nothing else in the entire car that could possibly be putting that kind of voltage on that wire. Diagnosis confirmed. All right, so we know what's wrong. Now comes the most important part, the fix. And listen to me very carefully on this. The order you do things in is absolutely non-negotiable. Get this wrong, and I promise you, you will literally be lighting money on fire. You'll destroy brand new parts and be right back at square one. Step 1. The PCM. It has to be replaced first. Period. No exceptions. Think about it. If you put a brand new sensor in and plug it into that bad PCM, what's going to happen? Zap. That PCM is just going to blast it with 12 volts and kill it instantly. So it's got to be new PCM first, only then, once you have a safe 5-volt signal again, can you go through and replace all the fried sensors and injectors. After that, you clear the codes and make sure it's all working.
Okay, now for the part nobody likes to talk about, the cost. Let's not sugarcoat it, this is an expensive repair. So let's take a realistic look at what you're up against so there are no surprises down the line.
Best case scenario, you caught it early. You're looking at a new PCM and a few of the main sensors. That's probably going to be around $2,000. Now, what's more likely is that you've also fried a bank of injectors. That'll push you closer to the $2,500 mark. And the worst case? Well, if all that raw, unburned fuel has ruined your catalytic converters on top of everything else, yeah, you could easily be looking at $5,000, maybe even more.
Okay, so you know the problem, you know the fix, and you know the cost. Now for the most important part of all, what you need to do right now to stop the bleeding and prevent any more damage from happening.
The first step is simple. Stop everything. Do not turn the key. Do not try to start the engine. Do not let anyone, not even your mechanic, replace a single part or run a single test. Because every moment that system has power, that high voltage is just silently cooking more and more components.
So here's what you're going to do right now. First, go to your car and disconnect the battery. Just pull the cable off. That cuts the power and stops the damage in its tracks. Second, call a tow truck. Make sure it's a flatbed. Do not try to drive it. It'll only make things worse. And when that tow truck drops your car off at the shop, you need to be confident. You walk in there and tell them exactly this. Tell them, the PCM's 5-volt reference circuit has failed high. Please verify the overvoltage, then replace the PCM before you touch anything else. Saying it just like that shows them you know exactly what's going on. It stops them from wasting hours of labor and your money chasing ghosts.
So let's wrap this up. The takeaway is this. This isn't just a few bad sensors. This is a catastrophic internal failure of your engine's computer. It is an electrical emergency. The only way to save your car and avoid a massive bill is to stop, kill the power by disconnecting the battery, and get it towed to a shop with those very specific instructions. The PCM has to be replaced first. Seriously, your car's life and your bank account depend on it.